Hi, my name is Sanay and my project is object detection with cars, and I'm going to be taking you through a step-by-step version of how I was able to achieve my first milestone, which was getting a testing model up and running on the supervised learning model NanoNets. So the first thing I had to do was find a data set for cars, and I was able to find a data set for many different images of cars and their corresponding annotations. So taking a look at images, we can see that there are over 8,000 different JPEG files, each of them containing a different type of car. For our purposes, let's focus on 00001.jpg, which is an Audi. If you go here and click on the corresponding annotations, you can see that there are two file formats, an XML and a JSON. And for our purposes, I was using JSON for this project. If you click here, you can see that there are corresponding JSON files which contain the annotations for each of the images that were in the file I just showed you called images. So let's just look at 00001.json and see what's in it. So going here, you can see that there are the annotations for the first one, which is the Audi for 0001.jpg. So you can see there's a bounding box and a name is 14, and the bounding box has xmin, ymin, xmax, and ymax. So you may be wondering what a bounding box is. Bounding box is pretty much, it helps the learning model NanoNet be able to predict cars based on the input, and it basically draws a box around each car that it wants to predict and use in its training model so that it's able to predict them in the future. And I think it's easier to have a visual understanding of it. So if we go here, we go to build and we go to annotate and annotate manually, you can see that I've been able to, from a Python script, upload all these different files into NanoNets. So let's click on 0001.jpg. You can see that this red box that is formed is the bounding box, and it's using the annotations, the xmin, ymin, xmax, and ymax to form this. And I was able to create a Python script called upload training.py, which pretty much runs a for loop through each of the images that I just showed you in the images folder and the corresponding JSON for it, and uploads the annotations for it into the images. So for example, it runs this for loop that looks at this and says, oh, okay, so the xmin is this, the ymin is this, the xmax is this, and the ymax is this. And then it runs the for loop for it and draws a box, and then the process continues over and over again. So as you can see, the 1 is the box is here, 2 it drew a box here, 3 it drew it like this, and it did it all through this coding script that I created based on the annotations that were provided in the dataset. And now you also may be wondering what these labels are. Now this is a very important part. The labels, since I was only able to use the free NanoNets version, it only allows you to use 5 labels. Each of these labels represent a different car make. For example, 3 would be Audi, 14, 3 would be Acura, my bad, 14 would be Audi. So if you go back here and you look at the name for 0001.jpg, remember I told you that it was an Audi, and you can see that its name is 14, indeed an Audi. So let's look at each and see what it is. So the label for 3, if you see, is an Acura. Forget the TL Sedan 2012, that's just extra information, but the overview, the broad category for each label, so 3 would be Acura, 14, like I've said many times, would be Audi. The other 3, I have 91, which would be a Dodge, as you can see here. 106 would be Ford, and 134 would be Hyundai. And for each of these different ones, Acura, Audi, Dodge, Ford, and Hyundai, I inputted 50 images for each of them. So for example, for an Acura, there would be 50 different types of Acuras and 50 different types of images that I've put for each of them, so that it has more content and more data to try to create a model from it. and this makes it more accurate and makes my testing model more accurate in that the more images you give it, for example 50 images, the more it's able to predict any type of card that looks like it or has the same symbol. So now let's go to my actual testing model and the model metrics. You can see that the accuracy is 99.53% right now. When I first started, it was about 88%, but I think because I've tested it so many times, it's learning more and more as I input more and more files, and it keeps improving and improving, which is why it's increased almost 11%, and it keeps fixing its confusion matrix and making amends to it. So go here. You can see that I've already called the API 43 times, meaning I've already tested different images 43 times, which is why my accuracy has been increasing because it keeps predicting and predicting, and it keeps making changes to make it more accurate. So for example, you can see that I inputted this image that is clearly an Acura, and you can see that it's very accurate and that it was able to predict the label as 3. And for example, this truck is a Ford. It was very accurate in that it was able to predict the label as 106. And remember, the accuracy is 99.5%, so it is very accurate for the labels that I provided. But there's one key thing to remember. If I put something else like Toyota, BMW, or Honda, it won't be accurate because that's not part of my data set. So if I put it, it will either give NA or it'll say that it'll just put a random label for it because it just doesn't know what to do and it's confused. So this only works for the 5 that I've given, the 5 labels, which is Acura, Audi, Dodge, Ford, and Hyundai. So I'll just take you through a step-by-step process. So Acura car images, let's just see what happens. I guess you can pick really any random one. I just pick this for our purposes. And you can see I already created an images test folder. Let's put this 2016 Acura, save it, go back to NanoNets, upload it. I have 2 of them, but I haven't used the first one before, so let's just see what happens. Ideally, it should be returning 3. I just wait for the response, and it returned 14. So that's one example where it actually went incorrect, which is why the accuracy is not 100%. But if you just pick another, let's say, random Acura, it should ideally this time give 3, because obviously it'll make mistakes like once or twice, but the model should be accurate enough to get it right. So let's say what's this one? And the JSON response should be 3, which it is. So just for testing purposes, I showed you 3 that were accurate, 1 that was inaccurate, just so you know that, my model can always be accurate. It's going to make mistakes sometimes, but overall, it is very accurate, as you can see by the accuracy threshold at 99.5%. And the more API calls I make, the more accurate it gets. And you can also do this from the Python script itself. You can upload different images from the Python script itself. So this upload, if I just call a random image and enter, it should be able to update it in the site itself instead of me just manually uploading in the UI. It should be able to do the same thing. So if, let's say, I press enter, wait a little bit for the results, and here it is. So the message is a success, meaning that it was able to input it. So its prediction is 106. So when I go back to the website, I should see that it's updated and another image has popped up here. And you can see, yes, another image has popped up. It's indeed a Ford and it's 106. So it works. So this is pretty much the entire model. You can either upload images from the UI itself, or you can upload it through the Python script, which I'd already created for uploading images. And that's pretty much my entire um, model. And basically what I want to do in my milestone 2 is create more models. So this one model has 5 labels, so I would ideally want to create 2 or 3 models to get 10 to 15 labels, so that I could be able to predict more cars and more types of cars than just the Acura, Audi, Dodge, Ford, and Hyundai that I can right now. And so yeah, that's pretty much everything I had to cover. And yeah, thank you.